Here we have a function. It's a linear function. How do we know it's linear? X to the first power, right? Well, I wonder if we can find what the inverse of this function would be. And of course, it'd be kind of a short video if we couldn't. So yes, we can. And the process is a relatively easy process that we can go through to find the inverse of this function. First thing we do is we replace f of x with y. And remember, that's what f of x represents when we think of a graphic representation of a function. The function's value is the y value. So first step to find the inverse of a function is you replace the notation f of x with y. Second step is to interchange the x and y variables. After you've interchanged the x and y variables, then solve that equation for y. So I would subtract 1 from both sides and divide by -3. So that would give me y equals, well, x divided by -3 is going to be negative 1/3 x. And -1 divided by -3 is plus 1/3. So one way to express the inverse of the original function we have here, f of x, is this expression. And using that inverse function notation, we would then write that f inverse of x equals negative 1/3 x plus 1/3. Or an optional way to express that would be negative x plus 1/3. Can you see that that would be equivalent? Which also then could be written as 1 minus x over 3. Do you see how all three of these expressions are equivalent? I simply put these two fractions together into one fraction, and then I rewrote it so that my leading coefficient here was positive and not negative. So all of these are ways to express the inverse function of the original function f of x. And remember, to really prove that we have correctly found the inverse function, we would have to show that f composed with f inverse and f inverse composed with f both equaled x. If we show that, then we have proven that these are indeed inverse functions. Let's take a look at another function and find its inverse. Let's suppose we have this function, f of x equals x cubed plus 1, and I want to find the inverse of this function. Again, step 1 is to replace the f of x notation with y. Step 2 is to interchange x and y. And then step 3 is to solve this resulting equation for y. So I'll subtract 1 from both sides. And then I'll take the cube root of both sides. So this is the expression cube root of x minus 1 is the expression of the inverse function of our original function f of x. And again, to prove that we have really found that inverse, we need to show that f composed with f inverse and f inverse composed with f both equal x. So again, that process is replace f of x with y, interchange the x and the y in the equation, solve the equation for y, and this expression then is the expression of the inverse of that original function. Let's quickly run through proving that these two indeed are inverse functions. So f composed with f inverse, where every place there's an x, I'm going to replace it with that entire expression. See, here's where x was in f of x, so I replaced it with the entire expression for f inverse. But then the cube of the cube root is just what we have there in the radicand position. Minus 1 plus 1 is 0. So sure enough, f composed with f inverse just gives us x. That's half of the proof. The other half of the proof is to show that f inverse composed with f also equals x. So wherever I have the x in f inverse, I'm now going to replace it with that entire expression. So wherever there was an x, I replaced it with x cubed plus 1. Plus 1 minus 1 just gives me x cubed. And the cube root of x cubed is simply x. And there's the second half of our proof, showing that f inverse composed with f equals x as well. So here we went through our process to find the inverse function of that original function and demonstrated that indeed we had correctly found it.